Welcome back to the Deep Dive. Today our mission is, well, it's a deep exploration into strategic independence. Specifically, we're looking at how a nation can fundamentally rewrite the terms of its own defense, its own security.
Right.
We've got a whole stack of sources here that detail a transformation that took place over decades, and we're going to pull out the key strategic decisions that really paved the way for self-reliance.
And that transformation, it's laid out in, remarkable detail in these materials. It traces what's very aptly described as the arc from dependence to deterrence.
A great title.
It is. And we're focusing squarely on the methodical, often very challenging evolution of Pakistan's defense industrial complex. It's really a textbook case study.
In what way?
A case study in how a national commitment, a real one, can overcome things like resource limitations and major geopolitical vulnerabilities.
Okay, let's unpack this. The central narrative here is it's exceptionally powerful. You're talking about moving from a state of total reliance on other countries,
A complete reliance.
where your security policy could literally be dictated by whether or not you can get spare parts.
Or if someone suddenly decides to impose an arms embargo on you.
Exactly. And moving from that position to becoming a sophisticated builder, an innovator, and a net exporter of advanced defense hardware.
It's the difference, as you said, between purchasing your security and truly owning it.
Owning it.
And that journey, it becomes remarkably clear when you trace it through the specific strategic visions of 4 distinct eras of military leadership.
Right. So we're not just looking at technology, we're looking at the leaders who drove it.
Precisely. We're drawing our analysis from key excerpts from the arc from dependence to deterrence. And we're supplementing that with some targeted historical and political insights from the book The Generals of Pakistan by Mr. Zaheer Ahmad Meer.
And what do those sources give us?
They give us a precise chronological roadmap. It shows us not just what was built, but who was behind the institutional change, the technological shifts.
That structure is vital then. It sounds like we're tracing this arc through 4 really distinct phases.
That's right.
So I've got the foundational layer, then a scaling layer, then a technological integration layer, and then finally this big digital transformation at the end.
And each phase built its capacity directly upon the successes, and just as importantly, the learned lessons of the one that came before it.
It's a chain.
It's a chain. And the high-level takeaway we see immediately is that this entire journey, it really demonstrates how visionary, consistent leadership can fundamentally transform a nation.
From what to what?
From being merely a buyer to a builder of power. It's an exercise in national patience, in technological absorption, and strategic foresight that plays out over decades.
And like you said, that shift, it doesn't start with the flashiest technology, does it? It starts with the heaviest, most fundamental industrial capacity you can imagine.
The absolute bedrock.
Which brings us to our journey's beginning. Phase 1, laying the industrial foundation, guided by the vision of Field Marshal Ayub Khan.
Field Marshal Ayub Khan is presented in all the material as the absolute foundational figure.
Right.
The central problem he was trying to solve was, it was simple but absolutely critical.
Which was?
In the early years of the nation, military hardware was almost exclusively sourced from allies.
Mostly the U.S. and Britain, right?
Primarily. And so, if those alliances wavered, if politics shifted, the entire defense apparatus could just seize up. Overnight.
Your tanks stop running because you can't get a fuel filter.
That's it. And his strategic insight was that national defense simply cannot be divorced from national industry. They are 2 sides of the same coin.
It seems obvious now, but at the time, that must have been a profound shift in mindset.
Oh, massive. The source materials really emphasize his core, non-negotiable belief.
Yeah, what was that?
That industrial capacity was the true shield of a nation.
The true shield.
And that's not just about building weapons. It's about controlling the entire manufacturing ecosystem that you need to sustain a modern military force.
Especially if you get into a long conflict or if you're diplomatically isolated.
Exactly. It's about recognizing the inherent vulnerability of dependency. If you have to rely on an external supply chain, you are strategically exposed. Period.
So what was Ayub Khan's response? How do you solve that?
His response was institutional. He knew that to counter this vulnerability, the nation had to master the production of the tools that make the defense components.
So it's an upstream investment. You don't start with a rifle. You start with the factory that makes the rifle-making machines.
You've got it. That's the key. So the sources, they really hone in on two key organizations he founded, and they served very different but equally critical functions.
Okay, let's get into those.
The first, and maybe the most strategically critical for long-term industrialization, was the Heavy Mechanical Complex, or HMC.
Heavy mechanical complex. That sounds foundational.
It is. You just said that you need to build the factory that builds the other factories.
Yeah.
HMC is where that happens. It wasn't built to produce bullets. It was built to produce the heavy machine tools, the massive presses, the large-scale industrial plants that you need for everything else.
So HMC is literally the factory that builds other factories.
The perfect description. It grants you mastery over large-scale metallurgy, over precision engineering capabilities you need for everything from a cement plant to eventually the hull of a tank.
So without HMC, any other defense project like a jet component or a tank chassis, you'd still be importing the specialized machines you need to make it.
You'd still be dependent, just one step further up the chain. HMC was designed to neutralize that dependency right at the source of production.
Okay, that's one pillar, a massive one. What was the second key institution?
The second one was focused on the more immediate high-volume needs of the active military, and that was the Pakistan Ordnance Factories, or POF.
Right, POF. So if HMC is the strategic long-term play.
POF was the parallel, absolutely essential tactical track.
In what way?
Well, if HMC gave you the capability for heavy, complex manufacturing, POF ensured the steady, reliable domestic production of basic, consumable defense materials.
So we're talking about ammunition, infantry weapons, explosives.
All the basic componentry. This is the volume production capacity that you have to sustain an army in the field.
It sounds almost, I don't know, less glamorous than HMC's grand strategic role. But I'm guessing the strategic importance of POF is all about controlling your own consumables. Is that right?
Absolutely. Think about it. What's the most critical vulnerability in any conflict?
Your supply lines.
Yeah.
Logistics.
Logistical sustainability. A tank is a very expensive paperweight if it doesn't have fuel and ammunition.
Right.
By mastering ordnance production domestically, right there at home, through POF, the nation removed the threat of some external power dictating the pace of a conflict by just turning off the tap for bullets or shells.
So the lesson from this era, which the sources sum up as security starts with steel, what does that truly mean when you look at these two institutions, HMC and POF, together?
It means that sophisticated deterrence, the ability to project real power, it has to be anchored in the most basic, self-sufficient industrial capacity. You can't skip this step.
So it's a national policy commitment.
A huge one. To prioritize heavy industry, to prioritize foundational engineering over, just buying quick technological fixes off the shelf.
And what else did this phase do?
This phase was about building the muscle memory for manufacturing excellence. It was about creating a skilled national industrial workforce from the ground up. It set the standards and it built the physical infrastructure that was necessary for everything that followed.
The very tangible, very heavy starting point. But foundational capacity, as essential as it is also, I guess, inherently limited in scope. It addresses your basic needs, sure, but it doesn't necessarily generate economic leverage or high-tech modernization on its own.
That's the next challenge.
So Ayub Khan built the foundation, but the next phase had to leverage that capacity. It needed to be about growth, about global reach, and crucially, about absorbing new technology.
Which brings us directly to phase 2, strategic production and global partnerships. And this is under General Zaheer Haq.
Okay.
The industrial foundation is set. You have this massive capacity for steel production, but that scale creates a whole new set of strategic needs.
Like what?
Like funding for further development and acquiring technology that the local industry, for all its strength, simply couldn't invent yet on its own.
So General Zaheer Haq's contribution wasn't just about maintaining or, expanding the physical output of HMC and POF.
No, not at all.
It was about integrating that output into a much more complex global political and economic framework.
That's it. This era was about strategic scaling, and crucially, it was about moving the defense industry from being a pure national cost center,
Here's a drain on the budget.
to becoming a potential revenue stream and a tool of foreign policy. This is the moment where local manufacturing begins its transition into global competitiveness.
And what was the underlying strategic philosophy that was driving this expansion? What was the big idea?
The key idea was achieving independence through, and this is important, diversified global integration.
That sounds like a contradiction. Independence through integration.
It does, but it makes sense. During the Cold War, relying solely on one superpower, as the nation had done before, was proven to be strategically unsound. You'd get these sudden arms cutoffs.
Right, the politics would change and the tap gets turned off again.
Again. So Zia-ul-Haq's strategy required looking outward, not for finished products, but for technology transfer and for co-production models.
Okay, that makes the shift to a partnership strategy absolutely critical. The sources detail the pursuit of joint ventures. Who were the partners they were looking for, and how did this diversification help manage that geopolitical risk?
We see a very, very clever dual approach here. First, there were these crucial, comprehensive partnerships with China.
A long-standing
A
relationship.
very strong one. This provided guaranteed long-term technical and logistical cooperation. We're talking large-scale platform production and assured supply lines, all free from the political conditions that often came with Western deals.
Okay, so that's one pillar of the partnership strategy. What was the second?
The second was building strategic alliances with various European partners.
So not just one country.
A mix. And this offered access to high-precision, niche technologies, things like avionics, specialized metallurgy, advanced electronics.
Things that might have been unavailable through the Chinese partnership at that time.
Exactly, or where European standards offered a necessary level of precision, especially if you wanted to get into export markets. This diversification was a hedge. It ensured that if political tensions suddenly arose with one bloc, the entire industrial engine wouldn't just grind to a halt.
It's a genuine geopolitical balancing act. You're designing your industrial policy to maximize the inflow of technology while minimizing your vulnerability to political pressure.
That's the art of it.
But how did these joint ventures actually work? I mean, how do they transfer technology and enhance capability beyond just, buying a license to build something?
Right, and this is the operational detail that often gets missed. These were not simple purchase agreements. They were structured specifically to mandate technology absorption.
What does that mean in practice?
It often meant they included strict local content quotas, meaning that a growing percentage of the final product, whether it's a small component, a subsystem, or the entire assembly, it had to be manufactured or assembled domestically.
Often using the capacity that was already built at HMC or POF.
Precisely. The foreign partner was, in effect, contractually obligated to train local engineers and help establish local supply chains. This is what turns a domestic industry from just an assembler into a legitimate co-producer.
And that must just accelerate the learning curve immensely.
Oh, it's the difference between learning how to drive a car and learning how to build the engine. The knowledge, the actual know-how, it stays in the country.
And that expertise then allows the nation to do its own deep maintenance, maybe reverse engineer key components.
And crucially, to innovate and customize the product line itself for your own specific needs.
So the measurable outcome of mastering all of this was a huge shift. And the sources, they really highlight this as the major achievement of this phase. Pakistan transitioned from manufacturing solely for its own domestic needs to achieving export capabilities.
That is a critical marker of industrial maturity. It's one thing to build for yourself. It's another thing entirely to compete on the global market.
Because to successfully export defense material, you have to prove you meet global standards of quality, reliability, and maybe most importantly, competitive pricing.
It's the ultimate validation of the industrial foundation that Ayub Khan laid all those years ago.
So what were they exporting? The sources mentioned the breadth of production, listing everything from tanks to ammunition.
And that range is highly significant. Basic ammunition is one thing. It proves you have volume and consistent quality control.
But exporting complex platforms like tanks, that's a whole different level.
It's a different universe. It involves integrating engines, transmission systems, fire control systems, high-grade armor plating. It demonstrates mastery over sophisticated system integration and very complex supply chain management.
So this proved that the local industrial chain was robust enough for even the most demanding international markets.
He did.
So the key lesson for this phase is summarized as strategic alliances build strategic independence.
Yeah.
What does that truly translate to? I mean, in terms of long-term economic and military viability for the country?
Okay, well, economically, the defense sector moved from being purely extractive, just drawing funds from the national budget, to potentially being a revenue generator.
Right.
Those export earnings create precious foreign exchange, which can then be funneled directly back into high-cost R&D and modernization projects. It creates a self-sustaining cycle of innovation.
A vital feedback loop is created.
Absolutely. And then militarily, independence means freedom from political conditionality.
The old problem.
The old problem. If a major supplier suddenly halts arms sales because of some political disagreement, the nation can draw upon its own production base, or it can rely on its diversified partnerships. It shifts foreign policy leverage in your favor.
Because you're no longer entirely reliant on a single source for your most critical assets.
And that resilience proved its worth time and time again in subsequent geopolitical crises.
Okay, so let's recap where we are in the arc. The industrial foundation is solid, the scale is now national, and global partnerships have provided the technological absorption you need for exports.
A very mature industrial base.
But technology, it just keeps marching on. The base, while mature, still needed to transition from, heavy steel and complex assembly lines to integrated, high-level modern warfare capabilities.
And this is where we see the most significant technological leap in the entire arc. The world was demanding platforms that integrated superior sensing, high-speed mobility, and network-centric capabilities.
Here's where it gets really interesting. We are now transitioning into Phase 3, entering the modern war machine. And this was catalyzed by the leadership of General Pervez Musharraf.
Right.
This seems to mark the integration of high-level, complex technology that really moves the defense industry firmly into the 21st century.
This era represents the strategic realization that simple production volume, as essential as it is, was no longer sufficient for deterrence.
The game had changed.
The game had changed. The core challenge became technological superiority. So if Ayub Khan established the steel and Zia-ul-Haq established the scale and the partnerships, Musharraf's tenure established the speed and the sophistication.
And the sources, they really focus on a symbolic and strategic lead that defines this period. Pakistan entered the jet age, and not merely as a customer placing orders, but as a co-developer and eventual builder of its own fighter jet.
And this leap is, you just can't overstate it, it's monumental. Moving from assembling tanks and ordnance to aerospace manufacturing requires an entirely different ecosystem of precision.
What do you mean by that?
I mean, we are talking about strict quality control for composite materials, dealing with supersonic aerodynamics, integrating incredibly complex radar and avionics systems, and managing extreme tolerances in manufacturing. This one industrial step signifies achieving an elite status in global defense manufacturing.
And we have two landmark defense platforms that are detailed as being produced during this period, and they show that this technological leap was applied strategically across both the air and the ground domains.
Correct. On the air side, the program that absolutely defined this phase was the co-development and serial production of the JF-17 Thunder.
The JF-17.
This multi-role combat aircraft program was a deliberate strategic choice. The goal was to acquire modern fourth-generation fighter capability, but to do it through a co-production model that maximized technology transfer.
So what were the specific political and industrial benefits of going down the JF-17 path over, say, just buying existing Western fighters off the shelf?
Well, the political benefit was stability. It was freedom from the threat of embargoes. It utilized that established partnership with China, specifically TCAC, alongside the domestic capacity of the Pakistan Aeronautical Complex, or PAC.
And industrially?
Industrially, it forced the entire domestic supply chain from HMC for the tooling to specialized facilities for the avionics. It forced all of them to meet aerospace standards.
It pulled the whole system up to a higher level.
It did. The domestic manufacturing contribution, which included assembly and crucial component integration, provided unparalleled control over upgrades, over maintenance, and importantly, over customization of the platform for their own local operational requirements.
So it's not just about building a plane. It's about building an entire ecosystem that has to be developed to support that aircraft throughout its entire life cycle.
Absolutely. And then on the ground, complementing that air power, we have the introduction and the localized production of the Al-Khalid tank.
And the Al-Khalid, this represents the pinnacle of their localized ground combat capability, right? It incorporates advanced armor, a powerful engine, sophisticated fire control systems.
And it proves that the nation didn't just cherry-pick high-tech air assets. All that continuous investment in heavy engineering, it paid off. It allowed them to produce a main battle tank, a critical asset for conventional deterrence that could stand alongside its international counterparts.
So the dual significance of these two platforms, the JF-17 in the air and the Al-Khalid on the ground, is pretty clear.
It's self-reliance at the highest level of conventional warfare capability.
The analysis points out that these weren't just imports. They represented a huge step in localized, sophisticated manufacturing capacity. But building the platform is one thing, actually utilizing it effectively is another.
And that's the critical point. Musharraf's tenure focused on a more holistic strategy of integrating technology and training to fundamentally create a modern war machine.
The hardware is only as good as the people and the doctrine operating it.
Exactly. This implies an institutional modernization that goes way beyond the factory floor.
So what kind of changes were needed in the training and the doctrine to match this new hardware?
Massive changes. It involved a real shift toward network-centric warfare concepts.
What's that?
It's where different assets, your ground troops, your tanks, your aircraft, your sensors, all communicate and share data seamlessly in real time.
So everyone sees the same picture of the battlefield.
That's the goal. And it required modernizing military academies, introducing advanced simulation and modeling tools, and creating specialized professional military education focused on integrated joint operations. You need highly skilled people who can not only fly the JF-17, but also maintain its complex avionics and integrate its data into the overall defense network.
So the implication here is that defense strength isn't just about the sheer volume of hardware anymore. It's about the skilled people and the effective doctrine you need to use it. It's the total system, not just the component parts.
And that's where we get the key lesson for this phase, as it's articulated in the source material. Innovation is the new deterrent.
What does that mean?
It means the focus shifts. It shifts from simply trying to outnumber an adversary, which relies heavily on that early industrial production, to outsmarting them. And that relies on technological agility and advanced force integration.
And the JF-17 is innovative because it was designed from the ground up to be customized and upgraded domestically.
Exactly, ensuring its long-term technological relevance, completely independent of external political pressures.
So we've journeyed from basic steel capacity to global export revenue, and now to these integrated high-technology combat platforms. But the technological horizon is, it's constantly shifting.
Always.
The industrial base is set, the modern hardware is in production, so the inevitable next step has to be moving beyond the physical domain of metal and mechanics and into the realm of pure data, the invisible infrastructure.
And that transition defines the final and the current phase of this arc. And it's probably the most rapid and institutionally demanding leap of them all.
Which is the transition from the analog to the digital theater of operations.
Right.
So Phase 4 is led by Field Marshal Zaheer Ahmad Meer, and it focuses on taking the defense industry squarely into the digital era. The contrast with Ayub Khan's initial vision is it's stark.
The core challenge of this phase is adapting an industrial and military institution that was built on steel and physical infrastructure to the new realities of data and software. The contrast is palpable. The foundational steel of the 1960s has now been supplemented and increasingly optimized by data.
And data is the new strategic resource. Securing it, leveraging it for defense, that requires a fundamentally different kind of national commitment than running a heavy mechanical complex.
It really does. It demands investment in intellectual capital, not just physical plant. It requires institutional courage to prioritize software engineers and cybersecurity experts right alongside your tank mechanics and your jet pilots.
And the source material provides detail on the cutting-edge systems being implemented that show this forward-looking posture.
It does.
So let's break down these new pillars of digital defense. And let's start with the one everyone is talking about: AI-based weapon systems. What are the specific, non-generic implications of leveraging artificial intelligence in this context?
Okay, so in a defense context, AI is primarily about two things: accelerating your decision cycle and enhancing precision in very dynamic environments.
So we're not talking about science fiction robots here.
No. We're talking about sophisticated algorithms being applied to logistics, to surveillance, and to targeting. For example, AI can dramatically improve the operational effectiveness of drone swarms, allowing them to coordinate in real time without constant human intervention.
What else?
It can perform predictive maintenance on high-value platforms like the JF-17, which dramatically increases their uptime. And it can fuse massive feeds from sensors far faster than any human operator ever could to identify priority targets.
So it basically turns information overload into a strategic advantage by automating the detection and response loop.
Precisely. It enhances the speed of deterrence, which is paramount in modern conflict. But of course, this hyper-reliance on data and network systems introduces massive new vulnerabilities.
Which leads us directly to the second pillar, cyber command.
It has to.
If your entire modern force runs on data, then the integrity of that data and the networks that carry it, that becomes your single most critical asset.
It becomes non-negotiable. Establishing a dedicated and robust cyber command structure emphasizes that you are treating the digital space as an essential domain of warfare, just like land, sea, and air.
And what does that involve?
It involves defending your critical national infrastructure, your power grids, communication networks, financial systems from state-sponsored attack, and it also involves protecting your internal military C4ISR networks.
Your command and control networks.
All of it. Because a successful, sophisticated cyber attack could potentially cripple the entire high-tech defense force that you built in phases 2 and 3 without a single shot ever being fired. The vulnerability is existential.
It's the unseen battlefront.
It is. And speaking of protecting integrity in a complex, networked world, the third pillar mentioned in the source material is highly innovative, especially in a logistical context.
Which is?
Blockchain logistics.
The blockchain. We usually think of that for finance, for crypto.
Yeah.
For defense logistics, it sounds incredibly complex. How does that technology manage a military supply chain?
Well, the defense supply chain is global, and it's notoriously complex. You're sourcing components for jets, tanks, advanced radars from dozens of countries.
Okay.
Blockchain provides an unalterable, distributed cryptographic ledger for every single component and every single transaction. And this is a game changer for two big reasons: traceability and trust.
Traceability makes sense. You know exactly where every bolt or microchip came from. But why is trust so critical in defense?
Trust is existential when you're dealing with microelectronics and sensitive alloys. Counterfeit components, or even worse, chips with maliciously implanted backdoors, are a severe threat to your operational security and the integrity of your platforms.
Right.
By using blockchain, every single item, from its point of manufacture to its final installation in the wing of a JF-17, is logged and verified. If a component lacks the proper blockchain signature, it simply cannot be integrated into that high-value system.
So it guarantees the provenance and the quality control that you need for high-stakes defense material.
It's a monumental upgrade to quality control and operational security. It creates an ironclad digital audit trail across a massive international supply network. It's the marriage of digital technology to physical production, directly improving the systems that were established in the earlier eras.
So the synthesis of this entire digital strategy is clear. The sources say Pakistan is now crafting defense through data.
That's the core of it.
This whole final phase, it just marks a monumental conceptual shift. We've moved from mastering the measurable weight and volume of steel to harnessing the invisible, algorithmic power of data and secure networks.
And this focus, it signals a national priority on generative capability, on developing bespoke, advanced digital capabilities that provide a unique edge. And the final lesson of this phase really summarizes the entire technological challenge of our time.
Which is?
Tomorrow's battles will be won by innovation, not imitation.
So this means they're moving past just absorbing imported technology and into generating new proprietary digital defense solutions.
They have to. You can reverse engineer a piece of steel, but replicating a cutting-edge proprietary AI doctrine or a unique form of cryptology is functionally impossible. You must innovate your own.
And that, I suppose, is the ultimate form of strategic independence.
It is. You transition from adapting foreign technology to dictating the terms of engagement through your own unique digital capabilities.
Now that we've covered the entire arc, let's step back and move into our closing reflection. We need to connect the dots across these four distinct military leadership eras, from the early 1960s all the way to today. It's a journey of incredible institutional endurance.
It really is, and it's crucial to see the continuity of purpose through all of it. When we look at the technological transformation, I think you can summarize the physical evolution beautifully.
How so?
It's the transition from rifles to rockets.
That's good. Starting with the reliable domestic supply of infantry weapons from POF, progressing through the localized production of sophisticated platforms like tanks and jets.
And ultimately mastering complex ballistic and cruise missile technologies. That is a qualitative leap in your power projection capacity.
A huge leap. And what about the industrial and the intellectual shift?
There, we've traced the evolution from assembly lines to algorithms.
Right. The initial goal was efficient, large-scale, mechanized production using HMC.
And the modern goal in Phase 4 is efficient, scalable, and secure data management for strategic decision-making, all managed by AI and blockchain.
This entire history, spanning over half a century, it seems to prove one fundamental truth that just permeates the source material.
And that is?
Nations survive when they build their own strength. Reliance on others for your core defense needs is a political vulnerability that severely limits your military viability and ultimately your sovereignty.
And this systemic, phased approach, which, remember, started with the heaviest, most basic industrial capacity, it provided the resilient foundation that was necessary to absorb the most sophisticated digital technologies today. The strategy was self-reinforcing, and that consistency is absolutely key.
So what does this all mean? Beyond the historical achievement of reaching this digital defense era, what's the current relevance of this arc for you, the listener, maybe for other developing nations that might be watching this model?
I think the primary relevance is twofold. First, it proves that modernization is an evolution, not a revolution. Stability and deterrence were achieved not through a single big purchase, but through a long-term, iterative, and diversified national investment.
And the second thing?
The second is that it demonstrates the necessity of adaptation. The strategic genius lay in Ayub Khan building the capacity to make steel, but the subsequent leaders had the courage to tell that established industrial base that now it needed to pivot to aerospace, and now it needs to pivot to software and data.
It also seems to demonstrate that a military modernization effort on this scale is a massive driver for civilian technology and education.
Oh, without a doubt.
You can't build a JF-17 or implement a sophisticated cyber command without a highly skilled national cadre of engineers, programmers, and technicians. The defense arc becomes a national skills development arc.
Absolutely. The ability to transition smoothly from investing heavily in foundational physical engineering, like HMC and POF, to prioritizing software architecture and blockchain logistics, all while still maintaining the production of legacy platforms.
Yeah.
It shows a remarkable degree of strategic flexibility and long-term planning capability.
It really is a powerful narrative of consistency, adaptation, and systemic resilience against geopolitical pressure.
And that consistency and that adaptive capability, it leads us directly to our final provocative thought for you, the listener, to mull over. And this is grounded entirely in the source material's chronological narrative.
Okay, lay it on us.
Given the rapid transition that we've detailed, from focusing on massive, large physical infrastructure like HMC and POF back in the 1960s, to integrating invisible, abstract digital infrastructure like AI, cyber, and blockchain today, how quickly must the national commitment to industrial self-reliance shift its focus? And what are the ongoing, perhaps even contradictory challenges of simultaneously maintaining robust physical production tanks, jets, munitions, which all require vast resources, while at the same time mastering the unseen digital domain of data and algorithms, which requires a fundamentally different kind of intellectual and financial resource allocation?
It's a constant resource-intensive balancing act.
It is, between supporting the physical legacy of the past and investing in the invisible imperatives of the future.
That question really captures the sheer complexity of modern defense strategy. How do you keep the massive industrial wheels of Phase 1 and 2 turning efficiently while rapidly scaling up the delicate, high-speed intellectual infrastructure that you need for Phase 4? A powerful note to end on. Thank you for walking us through this incredible deep dive into the arc from dependence to deterrence.
My pleasure. The story of transitioning from a buyer to a builder of power offers profound lessons for any nation seeking true strategic autonomy.